Good morning. In this lesson, we're going to look at expected frequency. Before we get started, I just want to congratulate and praise all of you for working really hard for learning at home. I know it's not easy. It's not the same as being in school with all your friends, but I think you're all doing a fantastic job. And just to remind you that whilst you are watching pre-recordings of my classes, that you do have Google Classroom to be able to contact me about anything should you need to, whether it's about maths, school, or anything in general. Okay, so what is expected frequency? Well, we need to make sure we understand the two words first. They're both keywords. Can you remember what I said in the previous lesson that frequency meant in mathematics? Did you say how many? If you did, then you'd be right. Well done. So if we expect something, that means that we think it's going to happen. So therefore, we think something is going to happen, and how many? Do you have an idea of what it might mean? It means that we're going to try and predict how many times a certain result happens. So, for example, flipping my coin, if I was to flip it 10 times, how many times, that word how many, frequency, would you expect to land on a heads? What do you think? So I'm going to flip this coin 10 times. How many times do we expect it to land on heads? Well, as there are two equally likely outcomes, two results which are both just as likely as each other, then we would expect that half of the results, half of the flips, half of the trials would be heads and half would be tails. Well, therefore, that means 5. 5 times we would expect it to land on a heads. Okay, so what if I was to look at something a little bit more challenging though? How many times, if I asked 50 people, how many times would I expect people to say that they owned a car? That one's not quite as easy. But if we can work out the theoretical probability, or if we can't do that, an estimate of their probability, which we can do through using relative frequency, where we learnt that we can actually conduct an experiment to get an approximate probability. If we know either of those, then we can work out expected frequency quite easily using a formula. And here it is. The formula for calculating expected frequency is the number of trials times the relative frequency, or the theoretical probability if we know the exact probability. Okay, well, let's apply that to our coin event first of all and check that it definitely does make sense. Okay, so we know that expected frequency is the number of trials times the relative frequency if we have some results from an experiment we've actually done. So we've actually performed lots of trials and we've worked out then the relative frequency from that experiment. Or if we've not done an experiment, but we knew all the outcomes to begin with, and therefore we can easily calculate the theoretical probability. So I don't need both, I just need one or the other, and I multiply that answer by how many trials it is that we're interested in. Okay, so let's have a look. How many times would we expect a coin to land on heads if it was flipped 10 times? Well, if you notice, look at the wording of the question really carefully. It has how many in it, which we know is frequency, and it has the word expect in it too. So that really helps us in an exam to remember that, it's asking us to do expected frequency. Okay, so the expected frequency is the number of trials. Well, the trials in this case would be the flips of the coin. and we multiply that by either the relative frequency. Well, we haven't been flipping coins lots of times and recording down the results, so I'm going to use the theoretical probability because we can. So if you recall, that was notated in this format, a capital P for probability of, and then in a bracket we would put what we were finding the probability of, the event of getting a heads. And let's just remind ourselves how we calculate the probability of getting a heads, theoretical probability. It's how many are there of the desired outcome that we want? So how many heads are there on a coin? And then over the total possible outcomes of that trial, all the results that can possibly happen when you flip a coin. Well, you could get a heads or you could get a tails. There are 2 total outcomes. There is 1 head out of 2 total possible outcomes. So the probability, the theoretical probability, is 1/2. So let's put this into our expected frequency formula then. So the expected frequency is the number of flips, the number of trials. If we're going to flip it 10 times then, how many times will it be a head? So it's 10 times the probability of getting it once, 1/2. 10 times 1/2 is 10 halves. 10 times 1 is 10. And that means 5 times, which is exactly what we had predicted earlier. But this demonstrates how the formula works. Your first letter to record down in your exercise copy is the letter F. Okay, let's test our new knowledge on the car ownership problem. So, in a survey, 40 out of 50 people that were asked owned a car. How many people would you estimate to own a car then if there were 3,000 people? Okay, so do we have theoretical probability here, or was there an experiment conducted and therefore relative frequency? There was an experiment conducted. They conducted a survey. They asked 50 people, do you own a car? So that meant that there was 50 trials. And out of those trials, 40 of them said that they did. So that means it's a relative frequency question. It then goes on to ask us, can we estimate how many, that word how many again, so the frequency, would own a car if there were a lot more people? Now this time it didn't use the word expect, but it still suggests that we do the same thing. Estimating means we predict, and expected frequency is always going to be an estimate. Whilst it's not random, it's calculated and therefore can be taken as fairly reasonably accurate, depending of course on how many trials were looked at in the experiment itself. If you recall from our lesson on learning relative frequency, the more trials, so the more people asked, the more accurate the results would be. Now, as we only asked 50 people, then our estimation here might not be quite as accurate as if we'd asked 500. Okay, so we know that expected frequency is calculated by looking at the number of trials that we are interested in studying on a larger scale. So if there were 3,000 people, and we multiply that by either the relative frequency or the theoretical probability. And because we have results from a survey, from an experiment, it's relative frequency this time. Therefore, it's 3,000 times, well, relative frequency was how many got the desired outcome in our experiment out of how many trials we conducted. Well, there were 40 out of 50 people said they owned a car. Now, of course, that is cancelled down to 4/5. So we can estimate how many people of 3,000 would own a car by doing 3,000 times 4/5. And the answer is 2,400 people. So what we've got is we're using effectively the same ratio of people that own cars to those in total for whatever number we're looking at. And that's what we're doing by multiplying it by that particular relative frequency or the probability. So like with our coin, it was a half of the number of flips. With the number of cars, it's 4/5. For every 5 people, 4 of them will own a car. So 4/5 of however many people we're looking at. So 4/5 of, and we know that of means multiply mass, 3,000. Let's put it all into practice. Let's look at an example of using a die. How many times can we expect to land on a 1 if we were to roll the die 900 times? Okay, so how many times would we expect its expected frequency? Okay, we know expected frequency is the number of trials times either the relative frequency or the theoretical probability. Well, I haven't got all the time today. I'm not going to roll the die lots of times and get the relative frequency, especially as we know that that's an estimate. Whereas we can actually calculate the exact probability of a die because we know how many ones there are and we know the total possible outcomes. So we're going to use theoretical probability. So our expected frequency then will be the number of trials, so that's our number of rolls, 900, times our theoretical probability. So the probability of getting a 1, which we know is 1/6. There is number 1 on a die out of 6 possible numbers. 900 times 6, 1/6. Now, of course, don't forget that multiplication is commutative. In other words, you can swap them around. So 900 times a 6 is the same as 1/6 times 900, which might actually help you to understand the formula a little bit better. Because what we're saying then is that the number of ones will be 1/6 of all the trials that we do. And of 1/6 of 900 trials. 1/6 of 900 rolls. Of means maths, means multiplication in maths. So therefore, we're going to end up with 900/6, which 900 divided by 6 is the number 150. So we would expect that 150 times, roughly, remember expected frequency, like relative frequency, is an estimate. It would be around 150 of those 900 that we would get the number 1. Your second letter to record down in your exercise copy is the letter E. Let's have a look at this example. We have a spinner and we're interested in having a good estimate at how many times, if we were to spin this spinner 600 times, would we land on a multiple of 3. So this is where knowing our keywords is really important, because you might be asked to find the probability, relative frequency, or expected frequency, like this one, of all sorts of things to do with mathematics. So a multiple means the multiplication of the times tables. It's all the numbers that the number 3 goes into, the 3 times table. So let's have a look and think. We know that expected frequency uses either relative frequency or theoretical frequency. Is there a particular one that I need to use here? Well, I could use both if I wanted to spend some time and to spin the spinner lots of times and do an experiment. I could find the relative frequency. But if we can work out the theoretical probability, then that's much better, because that's exactly accurate. So that's what we're going to use. We're going to use theoretical probability because we can. We can work out how many multiples of 3 there are on this spinner, and we know how many possible outcomes there are in total when we spin it. So let's work out first of all the probability then of getting a multiple of 3. So probability is how many are there of what we're interested in. So how many multiples of 3 are on this spinner? Well, the 3 times table starts with 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. Nope. There's only 2 multiples of 3 on this spinner. So the top of our fraction, the numerator, is the number 2. And we know that the bottom of the fraction, when we're working out theoretical probability, is how many outcomes there are in total. And there are 6 numbers on this spinner. So 2 out of the 6 are multiples of 3. And that can cancel down to 1/3, dividing the top and the bottom of our fraction by 2. 2 divided by 2 is 1, and 6 divided by 2 is 3. So the probability, theoretical probability, which we can calculate, so we're going to use that for our expected frequency, is 1/3. So our expected frequency then, we know is how many spins we're thinking of doing. Well, we want to know how many out of 600. So 600 times the theoretical probability, which we've just calculated, of 1/3. So 1/3 of 600 should be a multiple of 3. And we know that when we multiply a fraction by a whole number, it's the same as simply multiplying the whole number by the top numerator over the same denominator. Or, alternatively, you can add the over 1, so you can change the whole number into a fraction itself, which we know is simply by placing it over 1. And that doesn't change the number because it's still 600 divided by 1. That's still the number 600. But it's easier sometimes to do that to understand why we multiply the tops together. 600 times 1 is 600, and then the bottoms together. It's multiplying fractions. It's quite easy. Top by top, bottom by bottom. 1 by 3 is 3. And then, of course, this fraction is a division, and it's a nice even number of 200 times. 600 divided by 3 is 200. So roughly, I'm going to save myself a lot of time. I don't need to be spinning this round and round and round, but we should expect 200 of those 600 spins to land on either 3 or a 6. Please can you pause the video and record the following formula into your notes copy. Your homework today is from page 137, exercise 8.7, and I'd like you to do first of all question 1, where you have a variety of probabilities given to you and some trials, and you're to calculate expected frequencies. The last two are pretty challenging because you've got the answer and you have to figure out what was the question to begin with. And also then question 5, it's a study of cats and allergies, and then number 10, looking at some marbles. I would also like you to watch one of the Math Antics videos, which you will see on Google Classroom. Thank you for listening, and I shall see you in class the next time. Just for fun, what did Miss Foley's calculator say to her? You can always count on me.